Hello, my name is Magnus Creever, and I'm here to talk to you today about the effects of dietary algae on consumption, survival, growth, and production of the sea urchin Laryngitis variegatus. But before we begin, I would like to acknowledge VIP, Georgia Tech, and Georgia Southern for their continued support for this research, and my colleagues Destiny Solis, Ryan Gerald, Isis Sutton, and Michelle Lowry, with special thanks to Shanaz Lange and our project advisor, Dr. Anthony Siccardi. So, what are our goals for this project? We want to design, create, and execute a multifaceted project using biorenewable techniques that turn biomass waste into practical feed ingredients. Additionally, we want to analyze sea urchin growth, survival, production, consumption, and wet and dry weight. Finally, we look to enhance the current literature on sea urchin nutrition and the use of algae turf scrubbers. Our current innovations for this project is effectively to treat affluent wastewater that is constantly being released into the environment at high rates. Contaminants from this process contain varying levels of nitrogen and phosphorus, which further harm the environment. We propose an approach to utilize the ATS system to capture these nutrients and successfully use the algae biomass as a feed source in aquaculture. So here we have a video of the wastewater treatment plant. And the ATS is currently located here in Statesboro, Georgia.
Here we moved on to our ATS, which is approximately 30 feet long and is treated with 100% effluent. And it goes through this cycle and produces the nutrients we need in this biomass right here, which is later used for our sea urchin feed. This is harvested about once a week, and this is produces our results that we'll be using for the spring 2023 sea urchin research.
And here are materials and methods. So this is a video of me adding the water to the dry ingredients. This is the extrusion process, where the feed comes out in a pelleted format. And this is the end product. This is the collection process. We go down to Port St. Joe every year to collect the sea urchins. And this is our advisor, Dr. Anthony Siccardi.
We are currently in our 32-tank recirculating system with our sea urchins that we've collected. And we're actually going to be weighing this guy right here. All sea urchins have been size collected and acclimated already. This guy is 26.17 grams. I'm going to record it on my piece of paper real quick. And then we also have our ruler here so that we can take their size. Later on we'll use ImageJ or some kind of software program to collect the diameter. Alright. And each of these guys go individually in a case. And they go in one of these tanks, and there's 4 cages per tank, and each of them get fed individually with our pre-made diet.
So, polluted streams, waterways, and bays not only impact humans but also the organisms that live within those environments. The impact of fish die-off or fish kill-off can be seen through noxious odors and enclosed recreation sites. Our project will positively impact many environmental ecosystems as we implement the removal of the remaining nutrients in a sustainable and economic way that greatly reduces the risk of further contaminants entering our waterways. The ATS system additionally produces a biomass which can be utilized as a feed source in aquaculture. With regards to viability of a project, the costs associated with the ATS system are low due to a simplistic and ergonomic design. The ATS system is proven to remove nutrients, produce algae biomass, and operate year-round. The success of the project will be determined through a 2-step process. Firstly, sea urchin consumption of the ATS algae biomass, and secondly, sea urchin contaminant analysis, for example, concentration of contaminants such as serotonin-specific reuptake inhibitors. To conclude, our objective is to carry out the use of algae biomass created by the ATS system and produce a biorenewable feed for sea urchins. Additionally, aiming to remove environmentally harmful contaminants such as nitrogen and phosphorus from the waterways by introducing a cost-effective solution such as the ATS system. Currently, the sea urchin trials underway, and if successful, samples will be sent off for contaminant analysis. The full trial should be completed by January 2024. Thank you all again for listening to this presentation, and I hope you found it informative.